Hello everyone and welcome back to Computer Science for Everyone. In this video we're going to face our greatest challenge yet, which is deleting nodes from a binary tree. In this course, nothing is going to get more complicated than this. So I suggest we take it easy, go slowly and try to understand fully how this is working. In order for me to create this video, it took me 3 to 4 hours of working out the nodes and how to explain them in such a way that you would understand. So I wouldn't be surprised that it would take you as long to understand it. If it doesn't, then good job to me. But expect to take a few hours of working through this and how to delete and add and do things with the binary tree before you are able to fully program a working copy of this. So let's do it first, and then you can try for yourselves and see what happens. But first of all, let's try to create the last method that is going to be done in this video, which is the delete method. So this method is going to take an ID to delete, which is an integer, and it's going to remove that node from the binary tree. So let's remind ourselves of the 3 possible ways to delete. We can either delete a node with no children, a node with 2 children, or a node with 1 child, which I'm going to create here. So if we want to delete a node with no children, we simply make 3 point to null in its right, like so. We simply make 3's right point to null. If we want to delete a node with 1 child, for example 2, we make 3's left point to 1 instead of 2. So we'd essentially be deleting that and linking these 2 together, like so. And finally, we can delete a node with 2 children, like 3. If we're deleting a node with 2 children, we want to swap this node 3 for the rightmost node in this tree. So what I'm going to do is I'm going to change this to 8, this to 10, this to 6, 7, 2, 3, 4, like so. Just so it makes sense. Let's say we want to delete 6, then we would find the rightmost node in its left subtree. This is the left subtree. We'd find the rightmost node is 4. And what we do is we put 4 instead of 6. And 6, we remove it. So 8 would point to 4. 8's left would point to 4. 4 would then point to 2 and to 7. 3 would point to null. So there's a few changes we have to make in here in order to make it work. We need to make the 8 point to 4, 4 point to 2, 4 point to 7, 3 point to null. Those are the changes. However, we cannot think of this just in terms of the numbers. We need to think of it in terms of 3 is 4's parent. So the node that is the rightmost of the tree is going to get moved. That rightmost node's parent is going to have to point to null in the right. The rightmost node is going to have to point to the node that's being deleted, left and right. The node that's being deleted's parent is going to have to point to the rightmost node. So this then turns into this. It looks such an easy change, but it is actually quite complicated. Let's go into the programming and see how we can do this. Okay, so the first step is to find, as we know, the node we're trying to delete and its parent, because its parent is going to have to change and point, instead of to that node, to the rightmost node. Fortunately, we already have the find method, which we can give it an ID, and it gives us a node. And we have the find parent method, which I said would be useful. And that gives us the parent of the toDelete method. Okay. If toDelete is null, then there's nothing to delete. So that's that. However, if it isn't null, then we do the actual deletion. So there are 3 different potential options, I like to say it, if the toDelete has 1 child, 2 children, or no children. So that is one of them. That is the other one. And the last one is that it has 2 children. Like so. So what happens if it has 0 children? Let's say we want to delete 7. 7 is at the right of 6, which is the parent. So we simply know that 7 is at the right, so we set the parent is right to be null. 1 is at the left of 2, so if we wanted to delete 1, we would set 2's left to null instead of 1. So if toDelete equals the parent is left, we set the parent is left to be null. Else if toDelete is the parent is right, we set the right to be null. Else toDelete is neither the left or the right, then what can it be? Well, if toDelete is the root, find parent is also going to return the root. So toDelete and parent are the same if we're talking about the root. So the only other option is that the root has to be turned into null. So we can either change the left to null, the right to null, or the root to null. Because as we know, the parent of the root doesn't exist. There is no parent. Okay, so that is what happens if the number of children is 0. If the number of children is 1, it gets a wee bit more complicated, just a tiny bit. And once again, we need to check if we are at the left, at the right, or if we aren't in either of them. So, if we are at the left, we want to make the parent is left equal to a different node. This is what I'm trying to say. Let's say we want it to delete 3. We want to make 3's parent right equal to a different node, which is 4. We don't have anything to do with the left of the parent. So we have to check. If 3 is at the right, we change the parent is right to be 3's right. Or 3's only node, rather. Okay, so This is fairly complicated to explain as well. I'm kind of scared. If the I'll explain what I'm doing in a second. Okay, so here we know that to delete is at the parent's left, i.e., for example, in here, 1 is at 2's left. Now, if 1's left is not null, we want to make 2 point to 0. Else, it must be that this is at the right, let's say 1.5. So we want to make 2 point to 1's right. Remember, we can only have one node in here because the number of children is equal to 1. So if to delete get left is not null, then parent dot set left is to delete dot get left. So here what we've done is, let's forget about this for a second. So here what we've done is we have checked to delete get left is not null, which is 0 in this case. So we've removed 1 and we've set the parent's left, which is this, to be the left of to delete, which is 0. If to delete's left is not null, is null, then the right must be not null because we know it has one child. So we do the same but with the right. So here what we've done, if we've gotten the parent's left and we've pointed it at the right of 1. The other option is that to delete is at the right of the parent. So for example, if we wanted to delete 3. Now, it's going to be the same thing, but instead of setting the parent's left, we're going to set the right. So whereas here we changed the parent's left to be 0, now we want to change the parent's right to be 4, or the left or the right. So I'm going to get that and paste it here, and simply set the right. So if to delete's left is not null, then we set the right to be the left of to delete. So if 4 was here at the left, we would set the parent's right to point to 4. And then 3 would disappear. If 3's left is null, means the right is not null because we have one child. So we set the parent's right to point to delete's right, which is 4. Finally, if to delete get left, it's not null, else. Finally, the only other option is that to delete and parent are the root, so they're both the same. What we do here is we set the root to be equal to delete get left. This is the same thing as doing this, but I just thought that this is easier to understand. So if we are up here, then to delete is 8. To delete is not equal to the parent's right or left, because to delete doesn't have a parent. So then to delete, if its left is not null, in this case it has 2 children, but let's say it doesn't have this. So if to delete's left is not null, which isn't, it's 6, then we would simply make the root equal to 6, and we would essentially erase that 8. If not, if it was only 10, then we would simply make 10 the root and erase that 8, and 10 would be the root. So this is what we're doing there. I understand this is fairly complicated, and finding a way to explain it also took me a while. But that is the last part of deleting with one child. And now the last bit is the really complicated one that took me a while to try to get. But understand that it's going to take a while for you to understand it, and that you're going to need to try and draw it in paper or something like I'm doing with that piece of software, so that you fully understand how it's working. This is a complicated subject, and this is done in the last couple months of first year university computer science, so don't expect to understand it immediately. But if you draw it and try to understand what I'm doing, pause the video if you need to every now and then, and try to draw what I'm doing. I'm sure that will help, because it definitely helped me when I was studying it. Okay, so once again, we have the three choices. We have those three choices. And now, what do we have to do? Let's say we want to delete 6. 6 has 2 children. So we're going to find the rightmost node in the left subtree. You can either find the rightmost node in the left subtree or the leftmost node in the right subtree. In this case, I'm going to go for the rightmost node in the left subtree. It doesn't really matter, because I've already programmed the find rightmost method earlier. So I'm going to go for the rightmost node in the left subtree. So I'm going to get 6. This is going to be kind of my to delete. 8 is going to be the parent. I'm just going to add this in here. This is my rightmost node. So to delete method is 6. The parent is 8, as we were defined up here, to delete and parent. The rightmost node is going to be 4. So the first thing I'm going to do is I'm going to get the rightmost node. Like so, and I'm going to get this in all of them. So we have the rightmost node, which we know is 4 in this case. What else do we need? Well, we need to set 3 to point to null at the right instead of 4. So we're going to need the parent as well. We're going to need the parent there. So how do we get the parent? Find parent of the ID here. So we get rightmost's ID, and we find the parent of that ID, as we did with the method find parent that we created earlier. And we're going to do this for all of them as well. Okay, so now, what else? What other options do we have? What if we had something like this? I'm just going to create a new one here. I'm just going to put it here below. What if we had 8, 6, and then something like 2 and 4? Sorry, 2 and 7. Like that. Oh, my bad. Then this would be the to delete 6. This would be the parent. this would be the rightmost node up here. And what is the rightmost parent? Well, you guessed it. This one up here. It is to delete and the rightmost parent. So then we have a problem, because if we wanted to change to delete, we need to take into account that it is the same as the rightmost parent. Let's go back into programming and see what we can do with this in order to do something about deleting, because right now we only have the rightmost and the rightmost parent. So what I'm going to write now, I'll explain in a second. If rightmost parent okay, so why do I do this? If the rightmost parent is not equal to delete, then we set the right of the rightmost parent to be the left of the rightmost. Let's see with this example here, what would happen? Rightmost parent is equal to delete in here. So if we set the right of the rightmost parent to be equal to the left of the rightmost, we'd end up with null. We would end up deleting the 7. And we don't want to do that. We simply want to put the 2 point to the 7. As we know, we want to put the 2 in here, make it point to 7. However, if to delete and rightmost parent are the same, we cannot do this line of code. Let's take a look at what would happen in here, however. Rightmost parent and to delete are different. So if we set the rightmost parent is right to be the left of the rightmost, we get null. We are deleting this. And that is exactly what we want. We want to set the right of this to null, which is the left of here. Or if this had like something like this, then we would want to point this down here. This, put it up here. So setting this right to the left of the rightmost is what we want to do in order to continue the tree, only skipping this node. But if to delete and the rightmost parent are the same, then it is possible that to delete already has a node at the right, like we see here. And therefore setting that to be the left of here is not a good idea. So this is one of the checks that we had to do. The other one is this one. And I'm going to explain this now as well. Okay, so let's say that we have to delete get left is not equal to rightmost. So for example, in here, to delete left is equal to the rightmost. So if we set the rightmost left to be equal to deletes is left, then this would point to itself, because the left of to delete is the rightmost. Rightmost set left pointing to itself is not a good idea, because that would be an infinite loop. It would simply do this all the time. Oh, we don't want to do that. I know you probably couldn't see some of that, but that's fine. So if to deletes is left is not equal to the rightmost, we want to do that. Let's go up here and see what I mean with that. The left of to delete is 2. Do we want to set the left of rightmost to be 2? Well, yes we do. We want to put this 4 up here, and we want it to point to 2 and 7. So we do want to do that, but only if they are not the same. And we have seen why. Finally, rightmost set right to delete get right. Let me explain why we don't have any check with this. The rightmost node of the subtree doesn't have anything to its right. I think that's fairly self-explanatory. If it is the rightmost node, it cannot have anything to its right, because something to its right would be more to the right. So it would be, that node would be the rightmost. So our rightmost node doesn't have anything to the right. So when we move it up here, we want to change its right to be to 7. We don't have to check for anything because we know it doesn't have anything to its right. We know 6's right is what we want to put to this right. So we do that, and this is what we do with our line of code. And finally, we have to change the parent to be the rightmost node. So the parent is going to change its left to point to 4 instead of 6. And 6 is essentially going to be deleted after that. Why the left, you might ask? Well, because to delete is the parent is left. In the next one, to delete is the parent is right. So we do the same thing, but instead of to the left, we just put it to the right. So we copy that, put it there, change that to right. And finally, the same thing happens here just because that is to the right. So instead of setting the left to be the rightmost, we would set the right to be the rightmost. And finally, the same thing, but instead of the parent is left or the parent is right, it would be the root. If we were trying to delete the root, we would want to swap the 4 with the root so that it would point to 6 and 10 instead of anything pointing to 4, because 4 would be the root, doesn't have a parent. And this only happens if to delete is not at the parent's right and it's not at the parent's left. I know this is complicated. Hopefully with the help of this fantastic program, you would be able to understand it. I really recommend that you go ahead and try to program this yourself. Draw it on paper. Draw these diagrams on paper. Try to understand them fully. I know it's difficult. It took me a few hours to find a way to explain this and create the diagrams. So I'm sure you'll understand it. And please take some time to understand it, because in the next video we're going to move on to creating the controller, which is the easy bit. We're just going to create the menu and test the program out, see if it works. So please take some time to understand everything about deleting. It is the most complicated part of the course, essentially. So if you understand that, then congratulations, we can move on. And if you don't, please just take some time to try to understand it. So once you do, let's move on to the next video and create the menu and test our program out.